Today, Marnie Forster and I are going to talk to you about dating the timing of motion in major ductile shear zones. There is a lot of confusion in the argon geochronology world, in particular as to what allows movement in a ductile shear zone to be dated. Some people say that all you need is mica and you hit it with a laser and you get a plateau. But this is not at all sufficient to make the argument. In fact, we'll show that this is not the way to go. Argon geochronology, like all dating techniques, does not have the ability to date movement. It is the microstructural modification of existing grains that must be dated. For example, growth or regrowth, shredding of mica, cataclasis, or combinations. Or if we take argon geochronology in combination with ultra-high vacuum 39 argon diffusion experiments, we can get age spectra and Arrhenius data that we can invert to get essential aspects of the tectonothermal and microstructural history. And this is what I'm going to show you today. So let's begin by putting the question of using laser and that all you need is a plateau to rest. There is no theoretical or observational basis that suggests age spectra from metamorphic tectonites should approximate plateau, except under very specific circumstances. So let's choose a particular paper to illustrate this mistake. What I can show here is a age spectrum measured in the laboratory using furnace step heating in combination with a UHV diffusion experiment. And this is from the same locality as addressed by the Lee et al. Paper. What you can see on the left is a spectrum that gradually rises in the first 5% to a well-defined plateau. On the right, you can see that we can model that spectrum reasonably accurately. When we take the diffusion parameters we measure, we can actually estimate the temperature time curve. It'll form by rapid cooling in the order of 200 degrees per million years, rapidly cooling down to about 220, but you absolutely need to cool it no more than that if you want to replicate the shape of the age spectra. And it has to stay at about 220 for the next 400 million years, till about 1100. So an optimal circumstance for dating of the operation of the ductile shear zone is if it's shredded mica produced its diffusion dimension as deformation went on. This sort of behavior leads to a staircase age spectrum, and that sort of spectrum is very characteristic of fractal diffusion and can be modeled quite accurately. Such age spectra appear to be able to allow the distinction of the start and the end of shear zone operation. In some cases, the age of relic microstructures is also evident. So it's a very, very spectacular outcrop. It's found north of the road leading to Manicaran along the Bias River Valley on a little hydro road that leads up towards the ancient township of Malana. And it's a very spectacular outcrop on the side of this road. So very easy to access. We've taken quite a number of people there. This is a photograph of shear bands. The age spectrum contains information about the history of fabric development, as well as the information about the thermal evolution of the sample. There's a recurring theme. We're not going along with the oft-repeated claim that argon produces mainly cooling ages. Sure, there is effects of the diffusion caused by temperature history, but very often the pattern of age variation correlates with fabrics and structures, and that is not what one expects if it's cooling. So the microscope shows that there's mica and quartz in the older fabric, and these have been subject to annealing during the second of two Barovian metamorphisms that we think took place at about 22 million years ago. You can see decusate textures in the mica, but in the quartz, you can see relic foam textures. And these are formed only as a result of surface free energy, allowing grain boundary shapes to adjust. Surface free energy is a very low amount of energy, and it's quickly overwhelmed if there's any deformation going on the rock. And these foam textures were then overprinted by shearing associated with the main central thrust. So we have a tectonic sequence diagram, or a TSD, which shows a overprinted foam texture and sheared and shredded decusate mica. So we can show from this sort of result that the main central thrust in this part of the Himalaya operated from about 15 million years ago to 9 million years ago. So this study in the Northwest Himalaya has become a bit of a classic in how to combine argon geochronology with structural geology analysis. And you can see here's how many of the structures have actually been dated. And you can see that tectonic sequence diagrams are important because the detail on these tectonic sequence diagrams allows us to tie the deformation history into the actual numbers. It's when you put age data in context that these things start to have real meaning. But we can go further with the ultra-high vacuum diffusion experiments, the UHV diffusion experiments, and we were able to show that the muscovite in the main central thrust was a little bit more retentive than normal muscovite, and that the relict ages were held by the more retentive mica that degassed in the last 20%. And we actually have done thermal modeling using this data. A more difficult circumstance occurs when age spectra from fabric-forming minerals appear to be unrelated to the timing of movement. So, for example, they're formed in an early period of metamorphisms in the Jurassic, and where there's been green schist facies ductile shear zones that have overprinted them. One has to be a lot more careful with microstructures. People say, oh, they're synkinematic. No, they're not. They're older micas which have been sheared and sometimes recrystallized. But the micas we dated dominantly were relict and gave invariably Jurassic ages. However, when we looked in more detail and looked at the history that you can see in the Cup de Creos, in those truly spectacular shear zones that we visited with Jordi Carreras back in 2018, you can see that to actually date the intense period of green schist facies movement means we have to overcome the problem of inheritance. And the way to do that is really to date rocks in combination with ultra-high vacuum diffusion experiments. And so we did that with feldspar, and just show you one of the results. And very clearly you can see the age spectrum is complicated. It can be modeled, but the models gave a consistent rapid cooling from about 420 to about 250 degrees at the just shortly after the Eocene and the Oligocene transition had taken place. And since the mylonites aren't going to be mylonites except during the temperature range I've shown in blue there, from about 420, 430 down to about 300, then this rapid period of cooling can really be asserted to date the mylonites. The mylonites are typical rapid cooling mylonites. They have grain size reduction. Eventually they even form pseudotacholites, and the pseudotacholites have given a slightly older age, but they're less reliable because they incorporate a lot of junk when you use them. You have to be lucky. Definitely more work needs to be done. The bottom line is that dating a shear zone isn't something that you should do in isolation of the surrounding geology. In this case, the tectonic significance of the Cup de Creos is likely to be a right lateral strike slip shear zone formed in a transfer fault, accommodating rollback of the Tethyan subduction zone as it drags Sardinia and Corsica away from the European margin during opening of the Gulf of Leon. But what we're showing here is the remarkable coincidence in space when you put Corsica and Sardinia back into their Oligocene position about an oil pole in the northern part of the Gulf of Leon. So these examples suggest caution needs to be exerted in the dating of movement in ductile shear zones. Laser step heated is not suited for purpose. It provides no information about the Arrhenius data, so you can't do anything about that sort of information. You can't assess what sort of mica you dated. You can't assess this, you can't assess that. In addition, they don't produce spectra. They produce scattergrams, and these are consistently more scattered than furnace step heating spectra, and they do not replicate the observed and the consistent detail that is observed in age spectra. In contrast, robotic methods applied to resistance furnace step heating experiments offer a cheap, efficient, and reliable way to obtain the detailed age spectra that are necessary, and in conjunction with Arrhenius data are able to characterize the pattern of gas release and modeling and simulation of the results. Thank you very much.